Okay, let them join. I don't want to wait. Okay. Okay. Today we are gonna discuss very important and most useful things in the machine learning area. Okay. What is this? Probability and distributions. This is very important topic for machine learning. Okay. And this we have a couple of things. First, one definition we wanted to understand is called what is a random variable? Is a real valued function whose domain is the sample space of random experiment. Random experiment. It's in a real valued function. It's a real value function and whose domain is the sample space of a random experiment. Right? Lies like throwing a dice. Throwing a dice. What is my sample space? So it's in a real valued function. What is a here? Real value is function is nothing but it's a number of things. Write down. We will see this definition with a clear example. One example. We will take an example. Then we will. I'll gonna explain you what is random variable is all about. Done or not done? Okay. Now let us take an example of I am doing a random experiment as a tossing a coin. What is my sample space? Will be just equal to h. So two times I am tossing it, so it will come the eight outcomes. right? This is a basic 8 observations. Then HHT. First we are targeting with H T H H, and we will make H T H T T H T H T H T T T T T. This is my sample space of flipping a coin for 3 times. Clear? Now, now my question is, what is the probability? Now let us make x is a. Let us assume that x is my random variable. Let x is my random variable. What is the probability that all heads? What is the probability that all heads will you will get all heads? How many is the all heads? Mm, okay. See here we'll consider one, two, three. This is three, right? How many of two heads? How many of one head? No head. What is the probability of no head? Will be the zero. Guys, is this clear or not clear? These are called random variables. If you understood, type random variable. How many HH was there here? 3. How many 2Hs? These are the 2H possibilities. How many 1H possibilities? This. How many 0 possibilities? These are the 3 heads possibilities. 3 heads possibilities in one time, right? So here what we can write? No head equal to 0. One head equal to 1. Two heads. Three heads equal to 3. Hope this is clear. If you are clear, just type clear. Hey, what happened to the folks? Whether did they responded? One second, I'll be back. By the time you write down these notes. Guys, done? Noted down. Today we are gonna do a lot of mathematics. Seriously, you will feel that is this mathematics? Then I'll say yes. So without mathematics, you cannot do anything in the world. Trust me, take my word. Noted, Manikandan? Okay. Next topic. Now here. Now let us do something. Now I'll gonna write the same again. X of triple H number of three heads is this. Two heads is we will gonna write the distribution for this. We will gonna create a distribution table for this. Let us create x and probability of x. See 0, 1, 2, 3, right? This is called distribution table. So what is the probability of 0? What is the probability of that event happening is 0. This is tile, right? Tile happening is probability of tile. One tile will be 1 by 2, and this happening with this is what 1 by 8. Probability of 0. Clear? Yes, no, maybe. Okay. Now, for what is the probability for 1? 1 is 1, 2. Here also 1 by 8. Here is 1 by 8. Here is 1 by 8. What will be the 1? Will be 3 by 8. Here 1 by 8, 1 by 8, 1 by 8, 1 by 8, 1 by 8. Same thing. Here 1 by 8. When you do the sum, what will be this? We should get the probability should be sum of the cumulative will be what? Cumulative probability will be 1. Hope this is what the random variable. What is random variable definition? Random variable is a real valued function whose domain is the sample space of random experiment. Hope clear random variable with example. Clear or not clear? Okay. Now, hope you have taken the notes. Okay. Now we are going the some of the what are the things in random variable. So random variable can be two types. One is continuous random variable and discrete random variable. In continuous, what are the things it will come? Normal normal distribution and exponential distribution. And one more is Weibull distribution. Discrete distributions, Bernoulli distribution, binomial distribution, Poisson distribution, and geometric distributions. For machine, in terms of machine learning algorithms, these are the important. What are the important things? Normal distribution, these two, and I can say these three distributions are important. There is something called probability mass function and CDF, right? When we are working with continuous data, we use PDF. Write down this under this. When you are using discrete, we do use CMF, cumulative mass function. See, probability mass function, PMF. PMF is for discrete, PDF is for continuous. Is this clear? Now, now let us go some of the important things in terms of done. Okay. There are few definitions. One is first one is expected value of a random variable. Write on this. expected value of a random variable. I will take an example. Okay, let me talk about this one, right? We have talked about x 0, 1, 2, 3. Probability of x will be what? This is 1 by 8, 3 by 8, and this is again 3 by 8. This is 1 by 8. Here, the expected value. How can we write it as this? X into p of x1 plus x2 into p of x2 plus x3 into p of x3 plus x4 into p of x4. What we can write as a whole, expected value, or what we can call mean of, this is called mean of a random variable, or we can call it as a mu, right? So the expected value, let us assume, let us take an example. Now this is what the expected value, right? Now we will hold the start here. Now let us have a sample space. My x is my sample space of throwing a dice one time, right? This is what my sample space when you throw a single dice, right? What is the probability of x equal to 1? Will be 1 by 6. Probability of x equal to 2 will be 1 by 6. Probability of x equal to 3 will be 1 by 6. Probability of x equal to 4 will be 1 by 6. Probability of x equal to 5 also will be 1 by 6. Probability of x equal to 6 will be also 1 by 6. Now x equal to, now I am creating a probability table. 1 will be 1 by 6. 2 will be 1 by 6. 3 will be 1 by 6. 4 is 1 by 6. 5 also 1 by 6. 6 also 1 by 6. Now how can I write it this is? So what is the expected value? Will be 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6, 4 into 1 by 6, 5 into 1 by 6 into 6 into 1 by 6. This we can write it as a x into p of x. This term is probability of event happening of 1, right? Agree or not agree? So we are gonna extend this idea like mu equal to, how can we write, x1 into p of x1 plus x2 into p of x2 and so on xn into p of xn. So what is the expected value? I can write it as I equal sigma I equal to 1 to n x into xi into p of xi. Can we write it as this way? This is what expected. Why this is important we will see. First try to understand. Expected value equal to, hope this is clear. If you are clear in the expected value, just type the expected value. Done. Okay. Now, now, what is the properties, right? What will be the properties? Now we will see the expected value of a of x will be a into this way. Can I write it as this way? Now, one more thing. Expected value of 3 will be always, will not give you anything. It's in a constant term. Now, let us take an example of x. X equal to 1, 2, 3, 4. Right? What is an expected value? Will be 1 plus 2 plus 3 plus 4 by 4. This is called 2.5. Right? So, expected value of 5 of x, right? Now I am making as a expected value of 5 of x. What we can write it as? This will be 5, 10, 15, 20, right? 20, right? So, what will happen? 5 into, how can I write it? This is, what is the average of this one? 5 plus 10 plus 15 plus 20, 12.5. Can I write it as a 5 into 2.5? So, is this same as the formula? Constant into expected value of x. So, e of x equal to a into e of x. This is the one property which related to the expected value. Clear of this property? Property 1. Note it down. Done? Yes, no, everyone. Sharath, are you able to follow? Just mean, right? This is just average. We are finding the average. Now, we will gonna do some important thing, that variance. What is the formula for variance? X minus mu. Arre. Now we will take an example of variance. What is the variance formula? When we saw in the statistics class, x minus mu whole square by n. This is what my formula is, right? So can we write this formula into this way? p of x, each probability. So now we have seen the what is the expected value? Value e equal to e of f of x will be summation of f of x into p of x. Clear? This formula, can we write it as this way? Expected value of x minus mu whole square of variance. Can we write it as this way or not? Yes, no. Can we write it as this way or not? Guys, say yes, no, maybe. See here, this is what my expected value, right? This is what my formula. If this formula is this, we can make it as expected value as this f of x only, right? So I'm using this is what f of x. Is this clear? Shweta, everyone. You can write it on you can put it on your paper so that you will understand easily. Okay. Now what I'm gonna do, I'll gonna expand this logic actually. I'll gonna bring down the right now what I'm gonna do now. I'm gonna expand this idea. Right? Watch carefully. X minus mu. What is this? Square, right? I'll gonna expand this. I'm gonna write x square plus mu square minus 2 mu into x. Right? So I'm making it as expected of x square, expected of mu square minus 2 into mu into expected value of x. Right? We discussed expected value of x will be mu, right? So what I write it as x square plus u mu square 2 mu into mu 2 mu into mu 2 mu into mu. So what is a mu here? Mu is nothing but again expected value of here x square. I can write as here expected value is mu of x, right? So I'm writing as this as into this minus this I'm writing as this. So if you can simplify it, e of x square minus of e of x whole square. This is what variance formula. E of x square minus e of x whole square. See, this is the square of the event, and this is the expected value of this. You need to square it and do it. Find the probability, and this is the how we will let us take this variance equal to formula right on this. X square minus e of x whole square. Right? This is the variance formula. Clear? Clear or not understood? Now we know the formulas called two formulas we remember. Expected value will be x into p of x, and variance is formula is e of x square minus e of x whole square. So let us extend this idea. Let us have a sample space now. Okay, probability of event will be 1 by 4. Now I make it as a table. 1, 2, 3, 4. 1 by 4, right? Now first one is x square. So you multiply this. 1, 4, 9, 16. Then you calculate the expected value. This is what the this value. Then minus. You do the 1 into 1 by 4 plus 2 into 1 by 4 plus 3 into 1 by 4 plus 4 into 1 by 4. Then you find the whole square. You subtract it. That is what you will get the variance. What is standard deviation? Square root of variance. This is what the how to build the find the variance and expected value. Is this example is clear? Guys are able to understand variance and expected value. Now let us go and discuss the some of the distributions. We are going to talk the guys. If you are not understand the distributions, we are not going to derive any formula. One is called first one is Bernoulli random variable. Any idea Bernoulli process? The Bernoulli trial, right on this, talks about success or failure of a single experiment. If the okay, sorry, if the let us put in other way. The outcome is success or a failure Then the trial, the single experiment is called what? Bernoulli trial. Bernoulli Bernoulli trial. I'll write as a Bernoulli trial. It will give you the success or a failure. Right down. If the success is P, failure will be 1 minus P, because P plus 1 minus P always should come to the 1, right? This is our basic thumb rule, right? Clear or not clear? It's a Bernoulli process. If the outcome is success or a failure, then the single experiment is said to be a Bernoulli trial or Bernoulli process. On this process only, we developed. This is the idea for binomial distribution. Okay, sir, why do you want to learn all these things? Yes, we need to learn all those things because the data will be in like a different distributions. We wanted to understand which distribution data falls. So based on that, we need to apply the algorithms, or we need to bring the solutions for that. First, guys, you understood the Bernoulli process? Yes, no, maybe. If you are understood Bernoulli process, type Bernoulli. Okay, just go read it and understand. This is the then. This is the then. Okay. Sharath, are you not able to follow? Do you want me to explain again? Ch- Yes. Let us take Sharath. It's a just experiment. It's an experiment. When you are flipping a coin, flip a coin. If it comes head, it's success, and if it is tail, it's a failure. Flipping a coin. Let us consider flip a coin is a Bernoulli process. We call it as a Bernoulli process. Like whether we get only two outcomes. How many outcomes? The outcomes of the Bernoulli event will be only two events, either success or failure. Is this clear? This is what my experiment. I am doing a single experiment. Use the example of a flip of a coin. Now, Bernoulli trial is a process which gives me the success or failure. How many events we are getting here in Bernoulli process? Two events. Sharath, is that clear? Am I clear? Yes. Now we will do some mathematics now. We are gonna do mathematics. Please bear with me. Now probability of 1 will be P. Probability of 0 will be P minus Q. I can write it as this Q, right? Can I write this as a Q or not? Is there anything wrong? Bernoulli process. BP is a Bernoulli process. How can we write the table? X and x equal to 0 comma 1. What is the probability of x? Will be 0 is 1 minus p and 1 is p, right? Can we, this is the what the probability distribution table look like. Then what is my expected value? Expected value is summation of x into p of x. So what is this? 0 into 1 minus p plus, right, 1 into p. This is what? P. Expected value will be p and variance of it is nothing but e minus x ex square minus e of x whole square, right? Now let's understand here how can we write it as this. First we will do the e of x square, right? So it will be x square into p of x1 and x2 square into p of x2. How can I write it as this? 1 square into p plus 0 square into 1 minus p equal to what I'm getting? P. This value, right? Now we will see. Now this value will become what? P square, right? Till this point clear? Guys, understood or not understood? I have two formula. Here I have x. I'll place it in p square. E of x square I got what? P value. So my variance will be p minus p square, p into 1 minus p into q. Expected value is equal to p. Variance of x equal to pq. These two formulas. Guys, note it down. If you are not understood, these formulas will be handy when we do the exercises. Now, there is a one formula here. This is what I will note it down here. Noted means type the noted. Okay. Okay. Sharath here, right? These two lines. Okay. Let us understand. Now x equal to 0 and 1. P of x will be 0 will be 1 minus p. This is what my distribution table. Right now, what is the expected value? X into p of x1 plus x2 into p of x2. What is this? 0 into 1 minus p into p. So expected value will be p. This is what my equation 1. What is variance of x formula? E of x square minus e of x whole square. Right? First we are decoding here. We are trying to find x square. How can we write it expected as a x1 square into p of x plus x2 square into p of x. Now this becomes what? X1 square also it's 0 plus p. I got p. E of x whole square. Whereas e of x equal to p, this becomes p square. My variance becomes e of x square minus e of x whole square. Right? So here e of x square is what? P, right? This is what p I got. equation 2. This is 3. From 1, 2 and 3. I'm getting what? This is what? P minus P square. So P into 1 minus P. Can I write it as this? If it is a success is P of 0 is P. Success is 1. Failure is 1 minus P. I'll write it as a Q. So I can write it as a, sorry, one second. PQ. My expected value is P. My variance equal to P of Q. Make it as a 4. Sharat, is it clear now or not clear? Perfect. Okay. Now I told you for I told you what? There is a mass function, right? There is a mass function for discrete variables. Bernoulli falls in the discrete or continuous? Bernoulli falls where? Bernoulli process is only head and tail. There is no continuous. It's a discrete number, right? Agree? Here. Now we will go to. Let's keep that as a side. Now here. Now understand Bernoulli process. That's giving head or tail. It is say 0 or 1, right? So when it is saying 0 or 1, what we can say, it is continuous or a discrete? What is this distribution? These numbers. We call this as a discrete variables. What we call? Discrete. For discrete variables, I told you that for discrete variables, we use something called probability probability mass function. What is probability mass function for this particular thing? Write down this. P of x equal to p power x 1 minus p into 1 minus x. Now let us say when you have probability of x equal to 0, what will be the answer here? P of 0 into 1 minus p into 1 minus 0. P of 0 will be 1. This here will be 1 minus p. This is what we got it in a Bernoulli trial. This is what we got it. This is what a failure or success? Failure. If it is a P of x equal to 1, so 1 into 1 minus p whole power 1 minus 1. Anything power 0 will be? Anything power 0 will be what? Anything power 0 will be? Anything power 0 will be 1. So here we got x equal to 0 equal to 1 minus p. P of x equal to 1 equal to p. This is what the same thing that we are initially we thought of it. So this is what important. Probability mass functions are very important. Write down this. Is that clear? Probability mass function. One update going forward, we will be having classes on like Tuesday, Friday, Tuesday, Thursday, Saturday, Sunday. 4 days for a week. Tuesday and Thursday classes will be in the evening, and Saturday, Sunday will be morning. Does this make sense? So once it moves on, we will make it like every day, right? So we want to cover lot more topics. It's not like small thing. Now clear? If you are written, type the probability mass function PMF. Shweta, you didn't understood? Or no? Okay. Now next distribution is very important. Like we will see. First we'll talk mathematically, then I'll show you the slides. The next one is Bernoulli process, binomial distribution. Okay, what is the binomial distribution? You need to tell me. This is what we are studying of class 12th syllabus. This is what important for data science. It's not about like people will say 8th, ninth standard mathematics. Who wants that 8th, ninth standard? We want application oriented. Guys, any idea? Binomial distribution. How many of you not studied intermediate? Most of the people studied, right? Can you type in chat window? I'm gonna see you. What is binomial distribution? Shweta, you need to answer me. You are, I know you are the master at mathematics. Remember the only names, not but. Remember only name, but not theorem. Sharath, you should know Sharath. You are being good, going to be scientist. You should know in fingertips. This theorem, this theorem, this theorem. That is what I say. The data science job is not like a typical software engineering job. It's a like a s- scientist. I want to make you as a scientist. I don't want to make you as a like normal engineers. That is what the reason, whole idea about teaching you core mathematics. Are we teaching mathematics or not? Are we discussing mathematics which is relevant to data science or not? And I'm not teaching the math to your CBSE or IIT JEE here. Okay, we will see cool applications after this one. Binomial distribution. How can you say in Telugu? I don't know. Uh, I don't know. Shweta, I don't know Shweta. I also forgot the Telugu meaning. But I remember we was done lot many things in intermediate of this distribution. Okay, we don't want to waste the time, and yes, we are like see, binomial distribution. Let us take this. We were gonna do. This is what the building block. Write down this simultaneously. Write down. If you're not understood, stop it. The building block for binomial is is Bernoulli process. Bernoulli process. Point two. Okay, here we go here. Some small. Here, what we can write it as this way. We can write Bernoulli process is such that if we repeat Bernoulli trials n number of times, how many times? N number of times with a constant P. P is for success or failure. This is for success, right? Success in each trial is called binomial process. Don't worry about this. The typical definition. I will simplify this. Number of success in n trials. This is what the binomial distribution. Are we getting the examples that hitting target three times in 10 attempts? You remember this example, Sharath? This is what the binomial distribution talks about. Each trial is what? Each trial is what? Bernoulli, right? For each trial, you will get either failure or success. Here, n trials are fixed. Which is fixed? Number of trials are fixed. Do you understood or not? Yes, no. Shweta, Chennakesava, Sharath, Manikandan. Understood? The binomial distribution. Guys, clear or not clear? Shall we move to find the variable binomial distribution, expectations, and everything? Yes, no, maybe. Who joined? Sharad, are you able to understand? Shweta, binomial distribution. Guys, say yes, no. Okay. Now we are gonna see expected values and variance for the binomial distribution. Now let us assume, let us assume x is a binomial random variable. Okay, random variable means what? So I can write x equal to x1 plus x2 plus x3 and so on, xn terms, right? Xn. So where x1 and x2 and so on are xn are the Bernoulli tiles. What is this? Bernoulli tiles. What is the expected value of x? Will be e of x1 plus e of x2 plus e of x3 e of xn. So we need the success only, right? We need the success is what? P, right? So what we can write it as e of expected one will be p plus p plus p plus p. So I have n number of p, right? P1, P2 to Pn. So I can write it as a expected value is np. Can I write it as this expected value equal to expected value of binomial is np? Write down this. Once you're done, let me know. Those derivations. Everything is very, very important. We cannot leave out something that is not important. We need to understand. Done? Okay. Here, uh, what is a Bernoulli trial here? The in binomial process, we will do the experiment what n times, and we our expectation is number of success. Success is denoted as p. Right? I am doing n trials. So my x is my random variable. Right? Probability of x equal to x1 plus x2 plus x3 and so on xn. Whereas x1 and x2 are the Bernoulli trials. So every time I should get the p as my success. So expected value of this one will be p p p p p and so on. So np. So what is variance of x? Variance of x will be in binomial process. In like when we see the Bernoulli, variance will be pq, right? So I have n number of terms will be npq. This is what Bernoulli is the idea for for what? Binomial process. This is what the same as Bernoulli and binomial. Here, because we have n number of things, so we are adding the n here. Otherwise, same to same. Is this clear, Shweta? Now, I hold here also we'll get what? One probability mass function. Binomial is guys, you remember this formula? How many of you remember this formula? Where NCR equal to combination. Or else we can say n factorial divided by n minus r factorial into r factorial. That is the 5 factorial. 5, 4, 3, 2, 1. 1 factorial is 1 and 0 factorial is also 1. You go and do research why 0 factorial is 1. There is some long story for this. Can you remember this formula and this derivations? Guys, clear? Done? We will do some example also. Don't worry. I'm not gonna leave you doing of Python programming of this. We will do everything. Don't worry. First, we will do. I want to build you the concepts. So tomorrow I'll gonna ask you all the distribution, whatever we discussed, and what are the what is the one more distribution in the in terms of one discrete is a Poisson distribution. What distribution we call it? We will talk it as a Poisson distribution. This is what important for machine learning. Keep note this. This is very important for machine learning. I will tell you why this is what important. This is what the discrete numbers, discrete values. We discussed about machine learning with people will talk whatever the algorithms of currently we have, and all of the most of institute talks about only continuous values. My outcome is continuous values. Nobody talks about discrete value, right? So we will discuss about the one algorithm which talks about which is based on Poisson distribution. Now we call it as a Pasa distribution also. Pasa distribution, Poisson or Pasa distribution. What is Pasa distribution? Poisson distribution. Poisson distribution can be defined as number of events happening at a given interval time. Given interval time. Number of events happening at given interval times. This is what the Poisson distribution. Example: number of walk-ins to store given time interval, time between 9 a.m. to 10 a.m. Is this clear? Is this making sense of Poisson distribution or not? Yes, no. Understood, clear? Can be defined as number of events at a given interval, given time interval. That is what the Poisson distribution. And sometimes that we need to work on these models to build to understand what is the frequent, what is the number, what is the it's not could be the it's not like a continuous value, it's a discrete value. Will it gives the discrete value or continuous value? Discrete or continuous, guys? This give me discrete or continuous? Which one? This gives me the discrete value, right? We have a lot more distributions we will talk. Clear? If you say clear, just give me Poisson distribution. Guys, noted or not noted? Okay. Now here we will need to understand. Now for this, for Python distribution, statistics will continue for one more week also. But we want to learn a lot more stuff in terms of machine learning. We are not gonna. I hope we are learning enough of maths. Expected value will be NP, same as this. My variance also remains the NP into 1 minus P. So when the P value here is small, here here okay, from the definition of Poisson distribution is what we can write. It builds the concept of binomial. It's again it is Poisson is derived from binomial, right? What we can say here in this formula, like in NP, number of success will be small and attempts should be n should be more. Example I told, right? Number of n is large, right? So n is large, right? So here now expected and variance of x equal to np. So np I can write as mu or lambda. Lambda is nothing but average. Here is nothing but average. What is the probability mass function for this equal to e power minus lambda into lambda power r by r equal to what? X equal to r. This is what the formula is. Write down this formula, mass function. Done. You should have the probability mass functions in our fingertips. What is for Poisson? What is for binomial distribution? What is for Bernoulli distributions? And whatever the distributions you read it. But I don't see. I'm telling you, we have hell of distributions. But for data science perspective, we required some of the distribution. That is what we are discussing. If we want to discuss the distributions, it's like 1 year course. So complete distributions. Done? Noted? Now we will do some hands-on with doing with binomial distribution. Now we are going to do some experiment and solve the problems. Now in a binomial distribution, write down this formula. X has a binomial distribution with the parameter number equal to 10 and p equal to 0.25 percentage probability. What is the formula? What is the probability that student get no answer correct? This is the question. Write down this. Okay. Now my question is, what is the probability that student get no answer? Like what is the x equal to r will be 0, right? NCR into p power r 1 minus n power r n minus r, right? So what will be the answer? Guys, are you able to understand the problem or not? This particular problem. Guys, are you able to understand the problem or not? First of all, guys, say yes, no. Sharath, now this is what the we have the formula and we let us say the problem for the Poisson distribution. Okay. Now you write on this one. How the consider how where do we use the binomial distribution? Actually, this framework is very important. When do we use the binomial distribution? The number of heads in the sequence of the flip of a coins, vote counts for the two different candidates in election, the number of males and females in the company, a number of accounts that are being compliance or not in compliance with accounting procedure, and the number of successful sales calls, and the number of defective products in production run, and the number of day which month of the computer network is experiencing the problems. These all are the real problems which can be solved using what distribution? The binomial distribution. I'm telling you guys here, I'm stressing you the point here. Always the customer will not come and ask you, build a model and give me the answer. Build a model and give me the answer, right? Agree? They want that this kind of information needs to be understood. Is this, am I clear about binomial distribution or not? And when it comes to the Poisson distribution, here we have seen, right? Sigma square equal to variance np into 1p, 1 minus p. This is what variance is. Poisson distribution. See the Poisson distribution. The hourly number of customers arriving at a bank. The daily accident number of accidents on a particular stretch highway. The hourly number of access to the particular web server. Actually, this is what I we recently. This is what I want to share you one of my experience of recent my machine learning activities at office. And we were building. They are building the APIs. They are building the APIs, and we just wanted to understand the hourly access to the participants. How many hits are going to hit the how many users are going to hit the web server, particular web server. That is what we understood the probability of a given conditions, given number of users. This where we observed the Poisson distribution. We told that okay, we need to have the bandwidth to accommodate this users, this web server, and daily number of emergency calls and the number of typos in the book, the monthly number of employees who had options in a large company. Is this the, are you able to understand monthly demand for a particular product, right? If you take the Flipkart, if you take the Amazon, and they wanted to understand what are the monthly products, monthly demand for a particular product, so that what they can do, they can increase their stock in their business. So how this is being solved? Is it being solved? Is this being addressed with machine learning? Guys, yes, no, maybe. Sir, I don't know at all. Guys, clear about Poisson distribution or not? So this is what the Poisson distribution. Now let us say here the formula, right? The number of typical typographical error in a big textbook, the Poisson distribution is mean is this and 100%. So we want to calculate this. We can do some of the distributions in the Python programming. So this is what about the what distributions? We talked about discrete distributions, which is very important. Tomorrow we talk about continuous distributions. Today I am going. I have some other work. I need to go to school actually for my kids' parents meet actually. Even she is having. Even Shweta also having the same thing. So, do you have any questions about probability distributions? Are you clear so far what we done? So tomorrow we are gonna to complete the continuous as well as the Python programming. We are not. I'm not gonna leave you guys. So you said the concepts in. I'm not gonna leave you. Yes, clear. Yes, no. Shweta, done. Understood. Okay, done. So I what I will do, I will share the probability distribution one, or else you can. I have shared you the book, right? I have shared you the book. I remember, right? I have shared you the book. Which the book I'm talking. I'll show you what the book I'm talking. Here, go to this and open the chapter. Go to this book. Here we have a thing called. Everybody should read it. Otherwise, I will not gonna accept seriously. Distribution of the variable. Here we have done the now we have done the binomial distribution, and we will Poisson distribution. We have negative binomial distribution. We will talk tomorrow. Geometric distribution and normal distribution. This fourth chapter you should read and must read and come seriously. What is the homework for the day? Book number chapter 4. Clear? See guys, with your permission, I'm taking sign off today. Okay. I need to get ready for that for the school parents meet and have some other work. Is this fine, guys? Yes, no, maybe. Open intro statistics book, chapter number 4. Are you gonna read it and come right? Yes, no. Say yes. We are gonna read. Type read. Yes. Done, man. See you tomorrow, guys. Just be. Uh, I'll gonna make it in like their WhatsApp.